video, we're going to learn how to calculate with surds. But first of all, we need to answer the question, what is a surd? Well, if you did the square root of 9, you get an integer answer, that's 3. If you do the square root of 49, that's also an integer, 7. And the square root of 225 is 15. All of these give you integer answers, so they're not considered surds. If you did the square root of 2, however, you get this infinitely long decimal here. The square root of 38 is this one, and the square root of 416 is this one. These come out as decimals like this because the number inside the square root isn't a square number, and these numbers here are examples of surds. A surd is an example of an irrational number. This means that we cannot express them as a fraction. So if you try to write the square root of 2 equals some numbers a over b, where a and b were integers, you'll never do it, because it's impossible. You can also have surds which are cube roots as well, or even fourth roots. But for the purposes of the GCSE course, it's just going to be square roots. So you can think of surds as just being the square roots of numbers that are not square numbers. When working with surds, there are lots of different rules. First of all, let's look at the multiplication rule. If you take two surds, like the square root of 6 and square root of 5, and multiply them together, this is just the same as multiplying those numbers but inside one square root. So the square root of 6 times 5. We know 6 times 5 is 30, so this is the same as the square root of 30. You can also apply this rule in reverse. So if we took a surd like the square root of 12, this is the same as the square root of 6 times 2, which is the same as the square root of 6 multiplied by the square root of 2. There's also a division rule, and it works in much the same way. So if you take two surds, like the square root of 24 and the square root of 8, but divide them, this is the same as dividing those numbers but inside one square root. So the square root of 24 divided by 8. 24 divided by 8 is just 3, so this will give you the same value as the square root of 3. So we have a multiplication rule and a division rule. What about addition and subtraction? So if we did the square root of 7 plus the square root of 3, would that give us the square root of 7 plus 3, which is the square root of 10? Well, unfortunately it doesn't. It would be very convenient if it did, but this is not a rule. So you can't add surds together in this way. And it's the same for subtraction. If you had the square root of 20 minus the square root of 8, you couldn't write this as the square root of 20 take away 8, or the square root of 12. This is also not a rule. So these rules work for multiplication and division, but not for addition and subtraction. Next we're going to look at how you simplify surds. Let's take the surd the square root of 20. We know using the multiplication rule we could split this into the square root of 1 times the square root of 20, or the square root of 2 times the square root of 10, or even the square root of 4 times the square root of 5, since all of these are factor pairs that multiply to make 20. Now one of these is particularly interesting. If we look at the bottom one here, we have the square root of 4. The square root of 4 is not a surd, because 4 is a square number and we can square root 4. The square root of 4 is 2. Let's have a look at this one in more detail. So if we instead replace that square root of 4 with 2, then the square root of 20 is equal to 2 times the square root of 5, which we could write as 2 root 5. We just miss out the multiplication sign. 2 root 5 is considered to be more simplified than the square root of 20. That's because this number here inside the square root is smaller. So simplified surds have the smallest number possible inside the square root. Let's have a look at another example, this time the square root of 45. This could be split into the square root of 9 times the square root of 5, and the square root of 9 is just 3, so this is 3 times the square root of 5, or 3 root 5. So when simplifying surds, you're looking for a factor pair, but you want to make sure that one of them's a square number. Let's have a look at the square root of 98. Sometimes finding that square number is not as obvious. This one would be the square root of 49 times the square root of 2. Square root of 49 is just 7, so it's 7 times root 2, or 7 root 2. Now let's try square root 24. This is the square root of 6 times the square root of 4. And the square root of 4 is just 2, so this is the square root of 6 times 2, which you might think that we would write as square root of 6 and then 2. But this can lead to a problem, especially if you're a bit lazy with your presentation. Is that 2 inside the square root? Does that say the square root of 62? To avoid that ambiguity, we always put the 2 at the front. So in fact we need to reverse this and make it 2 root 6. This means when simplifying surds you want to put your square number first, so we probably should have done the working out this way round. Now let's try and simplify the square root of 48. I can see that 4 goes into that and 4 is a square number, so I'm going to go for the square root of 4 times the square root of 12. Square root 4 is 2, so it's 2 times square root 12, or 2 root 12. And at this point you'd probably think you'd finished because the number inside the square root is smaller, so we have simplified. But the square root of 12 can also be simplified. So if we go back a step, we have 2, but then we're going to split the square root of 12 into square root of 4 times square root 3. And that square root 4 is just 2, so we end up with 2 multiplied by 2 multiplied by square root 3. This time we need to multiply both of those 2's together. 2 times 2 is 4, so this is 4 root 3. This one's now fully simplified because there are no square numbers that are factors of 3. Apart from 1 of course, but if you use 1 the number won't change. The fact that we simplified this one twice tells us there was actually a bigger square number that went into 48. So if we go back, the square root of 48 could actually be split into the square root of 16 times the square root of 3. Square root 16 is 4, and then we very quickly get to the answer, 4 root 3. So the lesson here is to always try and find the largest square number, then you'll simplify as fast as possible. And we'll look at one more example now. We've got the square root of 15. When looking for factor pairs for 15, we've got square root 1 times square root 15, but that's just 1 times root 15, which is still root 15, so that's not helpful, and square root 3 times square root 5, but none of those are square numbers. So in this case we can't simplify any further, so this surd cannot be simplified. Now we're going to have a look at doing some multiplications with surds. Remember earlier the multiplication rule said that something like square root 6 times square root 5 was just square root 30. What if both of the numbers inside the surds are the same number? So square root 5 times square root 5. Well, if you multiply 5 and 5, you get 25, so this is square root 25. But we know what square root 25 is, that's just 5. So square root 5 times square root 5 is just 5. And this property works for any number. The square root of 8 times the square root of 8 is just 8. The square root of 2 times the square root of 2 is just 2. Now what if we multiply two surds together that have already been simplified, something like this? 3 root 2 multiplied by 4 root 5. Well in this case, let's put the multiplication symbols back in. So it's 3 times root 2 and 4 times root 5. Then we're going to multiply these numbers here, so 3 times 4, which gives you 12. And then we can multiply the surds, so square root 2 times square root 5, which gives you square root 10. So the answer to this question is 12 root 10. Let's try another one. So this one we would start by multiplying the 6 and the 3, which gives you 18, and then multiply the surds. Square root 5 times square root 11 is square root 55. Now sometimes you might get a question that requires more simplification. So let's try this one. Let's start with the 2 times the 5, which gives us 10, and then square root 6 times square root 3 is square root 18. But square root 18 can be simplified. So let's keep this 10 at the front, and split square root 18 into square root 9 times square root 2. The square root of 9 is just 3, so this is 10 times 3 times square root 2, and 10 times 3 is 30, so we end up with 30 times the square root of 2, so 30 root 2. You should always check when doing calculations with surds to see if it can simplify. Let's try one more. So 10 root 12 times 4 root 3, we'll do 10 times 4 first, that's 40, and then root 12 times root 3, which is root 36. This one's interesting though because the square root of 36 is just an integer, it's just 6. So this is just the same as 40 multiplied by 6, which is 240. Now let's look at some questions where we divide with surds. So a reminder of the division rule from earlier, if you do square root 24 divided by square root 8, that's just square root 3. Since 24 divided by 8 is 3. What if we had this one here? 10 root 30 over 2 root 10. Well, if we put those multiplication signs back in, we can actually write this as the product of two fractions. So it's 10 over 2 times root 30 over root 10. If we start with the 10 over 2, that's just 10 divided by 2, which is 5. Then if we move on to the surds, we have square root 30 divided by square root 10, And the division rule tells us this is the same as square root 3, since 30 divided by 10 is 3. So the answer to this question would be 5 root 3. Now let's try another one. So for this one, if we split it into those two fractions, now let's look at 10 over 15. That doesn't give us an integer this time, but we can simplify that fraction by dividing the top and bottom by 5. So that's the same as 2/3. Then if we move on to the surds, we've got square root 35 over square root 5, which is the same as square root 7. You can leave your answer as this, or it could alternatively be written as 2 root 7 over 3. Now let's try this one. So we're going to start with the 12 over 4, which gives you 3, and then we do square root 80 divided by square root 2, which is square root 40. Remember earlier I said we should always check to see if the surds can simplify, and square root 40 does indeed simplify. So if we keep the 3, and split the square root 40 into square root 4 times square root 10. The square root of 4 is just 2, so we can replace that with a 2, and then we multiply the 3 and the 2 to give 6, so this is 6 times root 10, or 6 root 10. And that doesn't simplify any further, so we're finished. And now let's try one more. 30 divided by 3 gives you 10, and then square root 45 divided by square root 5 gives you square root 9. This is a bit like the square root 36 one we had earlier, since the square root of 9 is just 3. So this is 10 times 3, which is 30. Earlier on, we looked at what happens when you add and subtract surds. So this one here and this one here. And these were not actually rules. So you can't add square root 7 and square root 3 and get square root 10. You can, however, add and subtract surds as long as the number inside the surd is the same number. So for example, square root 3 plus square root 3 is okay, and this gives you 2 root 3. You can also do square root 7 plus square root 7 plus square root 7 plus square root 7, and since there are 4 of them, this is the same as 4 root 7. This only works since the number inside the surd is the same. So you can only add and subtract surds together if they have the same number within the root. We can extend this idea to look at questions like this. 5 root 5 plus 2 root 5. This is a bit like when you have algebraic terms. If you add 5x and 2x, you get 7x. So what we're going to do is add the 5 and 2 here to get 7, and then it's 7 lots of root 5, or 7 root 5. So the number inside the root doesn't change, and we just add the numbers at the front. It's a bit like their coefficients. What about this question, 9 root 2 take 4 root 2? Well, we just do 9 take away 4, which gives you 5, and then it's root 2. So 5 root 2. And you can even do big ones like this. So here we have 6 root 7 plus 4 root 7, subtract 3 root 7 plus 1 root 7. So we can start with 6 plus 4, which is 10, and then subtract 3, which gives you 7, and then we need to plus 1 more, and 7 plus 1 gives you 8. So the answer to this question is 8 root 7. Now let's have a look at some questions which are similar to past exam questions. Let's look at this question here. Write 3 root 6 plus root 24 in the form a root b, giving the values of a and b. When it says in the form a root b, that just means we need to get our final answer to be a number, then a square root, then a number. For example, it could be 4 root 7, or it could be 8 root 2. As long as it's in this form, then we know we've got to the answer. In this question, we have two things that are being added together. But earlier we said we can only add surds together if they have the same number inside the square root, and these don't. One has 6 and one has 24. So we're going to need to do some simplifying first. We can split the square root 24 into square root 4 times square root 6. But we know the square root of 4 is 2. So if we write everything else in the question the same, but replace the square root 4 with a 2. So we have 3 root 6 plus 2 lots of root 6, which is 2 root 6. Now that we have the same number inside both of these square roots, we can add them together. We do 3 plus 2, which gives you 5, so it's 5 root 6. This question asked us to give the values of a and b, so we can see that a is the number in front of the square root, that's 5, and then b is the number inside the square root, so b is 6. Let's try one more. So this time we need to write this in the form a root 7, where a is an integer. So this time we've been told the number inside the square root is going to be 7, we just need to work out the number in front of the square root. So for this question, we're going to start with the square root 7 cubed. When you cube something, you times it by itself, and then itself once more. So it's square root 7 times square root 7 times another square root 7. If we multiply the first two of these square root 7s together, we get the square root of 49. And we know the square root of 49? That's 7. So it's 7 times root 7, or 7 root 7. Then it will subtract square root 63, which we could split into the square root of 9 times the square root of 7, since 9 times 7 is 63. The square root of 9 is just 3, so we can replace that with a 3. So it's subtract 3 times root 7, or subtract 3 root 7. Now that we have the same number inside the square roots, we can do 7 root 7 take 3 root 7. 7 take 3 is 4, so the answer is 4 root 7. This time we weren't asked to state the value of a. You can see that a is equal to 4, but it just says to write it in this form, so we've actually finished the question.